All right, good evening and welcome to today's class. Um, we're going to take it just straightforward without taking much time any longer. Um, let's look at some problems and their solutions, right, on this theory of logarithms that you have been working on all this while. Okay, now from the lowest, I'll just ascend gradually. Okay, let me say I have example. Let's apply what you have been learning all the while. Let me say I have log square root of 7 over log 7. Note that there is no base in this one, just like that. So what do I do? Straightforward. I just simply write this way. This is something as saying log. This 7 becomes 7 raised to power half. 7 power half all over log 7. Now, under power law, right, this will be transformed to half log 7 over this one return. Of course, this we cancel out this one. So at this point, I'm left with half. That's all about this. All right. The next one, let's look at another one that says, let me say example 2. Let me say I have log 14 to base 4 minus log 7 to base 4. Is that okay? Now, according to the law, this is a subtraction law. This is log 14 to base 4 minus log 7 to base 4. Now, because they have the same base, okay, the law says we are going to divide, okay? So the common thing here is log 4. Sorry, log to base 4, I meant to say. Then I will have 14, okay, divided by 7. Is that okay? So when I divide 14 with 7, I'm going to have 2. So I'm going to have log 4 to base 2. Is that okay? Now I can say let this equal to y. Now if I convert to index form, okay, I'm going to have 2 is equal to 4 power y. Now at this point, the next thing is to equate both the bases to have the same value. All right, I have 2 here. Okay, so I'm going to have, this is 2 equal to, now this side 2 should also have the same base, just like this 2. Remember that this 2 is more like saying 2 power 1. So this one I'm going to have 2 power 2 is 4. That becomes 2y, because if I write 2 power 2 times y, so that power 2 times y is this 2y here. So I will cancel out the 2 bases. I will equate the power. That means I'm going to have that 2y is equal to 1. Now to actually get my, what's it called? To actually get my y, I'll divide both sides by 2. So when I do, therefore, my y is equal to another half somewhere else. Let's go another one. Let's go. Let me take example 3. Example 3 says log 4, so log 32 to base 4 plus log 2 to base 4. Is that okay? Now, this is plus. Remember, what was it called? This is addition law. So when we have addition, we're going to multiply. but this and this have the same base. So the common thing here is log 4 and log 4. So I'm going to have log to base 4 outside. So I'm going to multiply this and this. Is that okay? So I'm going to have 32 times 2, which is 32 times 2 is 64 to base 4. Okay, now at this point we are actually going to do something here. It follows that I can make this thing now to be 4 to a power. This is 64 now. Okay, this can be written as 4 power 3 is 64, which is a 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Okay, so that is 4 power 3. So this one, using power law here now, I'm going to have 3 log 4 to base 4. Now this is log to its base. Log to its base is equal to 1, which is when I have the base and log to be the same thing, the value is 1. That means this whole thing here is 1. So that I'm going to have that 3 times 1 is equal to 3. That settles it. All right, good. Let's even solve more. Let's solve more. Let's solve more. Let's solve more. Let's have more examples. Let's have more. Let's have log 8 to base 4 minus log 32 to base 4. Okay, now to make it easy, let me just break this log to be on to have the same base, just to bring it down, 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 down. Now let's do this way. I have this thing can go this way. Log 2 power 3 is 8 minus log 2 power 5 is 32 to base 4. Implies that applying power law here, this 3 here as power is going to multiply this log 2 base 4. I'm going to have 3 log 2 base 4, okay, minus the same thing happens here. This 5 as index multiplies log 2 to base 4. So 5 log 2 to base 4. Is that okay? How do I go again? How do we go? How do we actually go now? Now, no. There's something I would like us to actually do here. I think my question is not correct. Meanwhile, let's go that way. Let's go. Now, at this point, this is log 2 base 4, log 2 base 4. Okay, now we're going to see something here. This is a 3 times this, sorry, this is 3 log 2 to base 4 minus 5 log 2 to base 4. Now if you actually watch here now, what I have common, what is common here is this log 2 to base 4 is common here now. So I bring it outside. Okay, then I'm going to have something like this, log 2 to base 4 into bracket 3 minus 5. Note that subtraction law does not affect this thing at the back. It affects the main numbers here. Is that okay? It affects the main numbers here. Okay, let's continue. Log 2 to base 4. Now 3 minus 5 is minus 2. Is that okay? Now let's work on this particular log 2 to base log 2 to base 4. Okay, now recall that log 2 to base 4 is equal to, I think it was solved somewhere before. Yes, it was solved somewhere before, which is this. So, and we got half. That means log 2 to base 4 is half. All right. Recall that log 2 to base 4 is equal to half. So that means if I should replace this with half, I'm going to have half multiplying minus 2. Okay, so this cancel this. I'm going to have minus 1 here. So 1 times minus 1 is equal to minus 1. That is that for that. Okay, I think we just have it here. Probably rest your mind and go through the solutions gradually, and gradually. We're going to take more tomorrow. So kindly do not, for any reason, miss tomorrow's class. I beg of you. All right. Okay. For now, bye.